guys, welcome to my system design series. Today we are going to dive deep into a fascinating topic such as schemas, specifically the writer schema and how tools like Avro handle them. If you have ever wondered how the data is encoded, transferred and decoded effectively without losing the information, this session will clear it up to you. Stick around till the end as we will discuss some practical examples to make things super easy to understand. Let's start with the simple basic. What is writer schema? When we encode the data, whether it is a storing a file, transferring the data over a network, or saving something into the database, we need a format or structure for that data. And this structure is we call as schema. Think of it as a blueprint of data. I have explained this in the previous video. So watch the previous video and then jump on this. If you are building a house, the blueprint tells you where the doors, windows and rooms should go. Similarly, a writer schema tells the system how data is organized when it is being saved or sent. But here is the catch. How does the reader know what blueprint the writer have used? If the reader doesn't have the same schema, the data become gibberish. Let's explore this with an example. Imagine you are writing a recipe book and sending it to a friend. You have written down the ingredients and steps, but your friend speaks different language. Without translating the recipe or providing some kind of guide, they won't understand it. Similarly, the writer schema is the translation guide. Writer schema is translation guide. It tells the reader's system how to interpret the data. But wait, should we send the entire guide or schema with every single recipe? That would make the book bulky, right? This brings us to the key challenge. How does reader know the schema without making things inefficient? Imagine every piece of the data, even the small one, came with the giant schema attached. It would be like sending an entire dictionary with every sentence. Avro solves this problem. The solution depends on the context in which Avro is used. Let's explore three scenarios. Scenario 1, that is, first imagine you are working with a large file, say a data set with millions of user profiles. It is stored using the same schema for all records. In this case, Avro allows you to include the schema just once at the beginning of file. This is super efficient because you don't repeat the schema every time for every record. For example, think of storing details of million students, that is name, age, grade. If the schema is included just at the start, all the students can follow it without repetition. Simple and efficient, right? Let's explore the second scenario. Now, what if the records are written at the different time and the schema evolves? For example, let's say imagine you are managing the database. One day you add a new field, that is preferred language, to the user profile. But the older records don't have this field. Avro handles this by adding the version number to each record. And here is how it works. When writing the record, the system tags it with the version of schema, and the reader fetches the schema version and decodes the record accordingly. So, even if the schema changes, the system remains backward compatible. Cool, right? Let's look at the third scenario. Finally, let's look at the network communication. Imagine two systems, a client and a server, talking to each other. How do they agree on a schema? Every solution is to negotiate the schema version when the connection is established. Both systems then use this schema for the duration of their conversation. It is like agreeing on a common language before starting a discussion. Now, let's compare Avro to the tools like Protobuf and Thrift. One big advantage of using Avro is it doesn't use the tag numbers in its schema. If you don't know about tag numbers, then please watch previous videos. It will help you to understand the further topics better. So, why does this matter? Well, imagine that you are exporting a relational database. Each table will become a record schema and each column will become the field. With Avro, you can generate the schema dynamically from database structure. And if the database schema changes, say a column is added or removed, you can generate the Avro schema without worrying about tag numbers. This makes Avro flexible for use cases like data export. Okay, let's take in practical example that if you are exporting the data from users table, okay, it has the columns for id, name, email. Tomorrow, you add a new column called phone number. With Avro, you can just update the schema and export the data without breaking anything. The new data files will still be readable by the system using the old schema. That is the power of dynamically generated schemas. In statically typed languages such as C++ or Java, tools like Protocol Buff generate the code for your schemas. This works well for the type checking and efficiency. But in dynamically typed languages like Python or JavaScript, this extra step is necessary. Avro shines here because it doesn't require code generation. You can open the Avro file directly, look at the data and start analyzing it just like you would with a JSON file. This makes it super useful for data processing tasks. Okay, so let's recap quickly what we have learned today. The writer schema acts as a blueprint for encoding or decoding the data. Avro solves the schema challenges using context specific solutions, whether it is files, databases, or networks. Its support for dynamically generated schemas makes it flexible and easy to use, especially for evolving data structures. Okay, so that's it for today's video. Please make sure you like, subscribe to this channel, and if you find this video helpful, share it with your friends. Comment down your doubts, your suggestions, and I would be happy to answer. See you in the next video.